recording. All right, so I'm just going to start out right at the basics, and then we're going to jump to Excel, because this is all done. This week is done in Excel, but before you go in Excel, you have to know what a line is. And in math, we use the symbols y equal mx plus b. So x and y is a point on the line, and that's how you represent a point with x and y. So those are our variables. M, the number in front of the x, okay, so the number in front of x is always the slope, no matter what order. This could be in a different order, but if there's a number in front of x, then that would be the slope, which I'll talk a little bit about. And this number that's added, b is just a number, is the y-intercept, and the y-intercept is where it crosses the y-axis. So this is just a short review on lines, but if I did y equal 2x minus 7, that would be an example of a line equation. And how do I know it's a line? Well, the x is like first degree, which means exponent 1. Okay, it's not squared, it's not cubed. There's no exponent on the x except 1. So it's just plain old x and plain old y, and that tells me that it's a line. So the slope, which is 2 here, so the slope is 2 over 1. We write it as a fraction, but the definition of slope is rise over run. So rise means we move up or down, and run means left or right. So rise is up and down, run is left and right, or vertical divided by horizontal. So this means for every 1 unit right, since it's positive, we move 2 units up since it's positive. So this is our rise, positive 2. So the bottom is left or right, and it's right because it's positive. So for every 1 unit right, we'll move 2 units up. So up and right would be our slope in this case, since they're both positive.
Okay, and I think I remember this from like high school math. So if, for instance, if the top number said -2 and the bottom was a +1, you would move to the right 1, and then you would go down 2, right?
Yes.
Okay,
yes.
just making sure I remember, because I was like,
Yeah,
why is it run? I know this one. Okay.
Okay, good. Awesome. Okay, so I'm just going to graph it real quick, like how we graph lines. So again, it's y equal 2x minus 7. This right here is the y-intercept. So that's the point 0, -7, and that's where it crosses the y-axis. So we go down 7. 1, 2, 3, 4, 5, 6, 7. So this is down -7. So x is 0 here because we're not moving left or right, and -7 means down. So that's where we start. That's our first thing we do when we graph a line is graph the y-intercept. And then from there, remember, then we do the slope. So this is number 1. This is number 2. It's 2 over 1. So we move right 1, up 2. So from this point, we're going to move, let me change color. We're going to move right 1 and then up 2 units, and we get our other point. So the first thing we do is graph the y-intercept and then move right 1, up 2 from that point, and then that's going to be our line. We only need 2 points for a line, and there it is. So this is what we call it. This one has a positive slope because it's increasing. And then if the line was pointing down, left to right, we always read a graph left to right. So as we move left to right and it points down, then our line would be decreasing. Like you said, if the slope was -2 and I'd move right 1 and down 2, then our line would be decreasing. For a negative slope, decreasing. So I could write that here. Negative slope, the line would be decreasing. Okay, then let's just do an economic example, the demand line. So for the demand line, we have price and quantity. So X is our price and Y is our quantity. So price versus quantity. So as the price increases of a product, just think of, gas. As gas increases in price, then the quantity that's sold would go down. You buy less gas. So this would be a decreasing price, and the equation would look like Q equal MP plus B. And again, M is our slope and B is our y-intercept. So this is just the same thing as y equal mx plus b, except we have price and quantity. And so for this example, I'm going to take this equation, that's a line. And so let's say these are theater tickets. So again, when the price of a ticket goes up, then less tickets are sold. That's the theory, at least. I mean, that's what usually happens. Okay. So one thing you'll have to do in the homework is, like, they'll give you that equation and what happens when the price is $40. So all you're going to have to do here is what's the quantity when the price is $40? So Q, you're just going to plug it in, equals 20 times 40 plus 2,400. So price is 40. You're just going to plug it in for this P. So put 40 in for the P, and you get minus 20 times 40 equal plus 2,400. So that's 1,600. So what that told us, and again, we're just going to do basic math here just to introduce you to lines. So what that told us is that when the price is $40 per ticket, 1,600 tickets are sold. Okay, so the demand curve looks like this, it's decreasing. And it has a negative slope because as price increases, the quantity decreases. You buy less. Okay, and just going backwards, what happens? Okay, so here's just going backwards, when 1,000 tickets are sold, what is the price of each ticket. So before we knew the price and wanted the quantity, this time we know the quantity and want to find the price. So again, we start out with our line equation, and we have 1,000 for our quantity. So this time 1,000 goes in for the Q, and we're trying to find the price. So this is going to take just a little bit of algebra. So if you remember algebra, you have to get P by itself. In order to do that, you start outside and work your way in. So we're going to subtract 2,400 from each side. That's the first step to get rid of it. So whatever you do to one side, you have to do the other side. That's 0. So then we have minus 20p equals minus 1,400. And then 20 times p is multiplication. So the opposite of multiplication is division. So we divide both sides by negative 20, and that's 1. So the price is 2 negatives make a positive. So this is going to be $70. So the price is $70 when 1,000 tickets are sold. So that's $70 per ticket. Each ticket is $70. So I just showed you in the homework, you're gonna have to go, I think it's in the Connect. It might be in the assignment. You have to go backwards and put your value in for Y and solve for X. But I think that's the most difficult part of it if you hadn't had algebra in a while. Okay, and then talking about lines, I'm just going to mention the supply curve. Since we were talking about business, the supply line, when the price goes up of an item, then the supply increases because you're not buying those items because the price is high. So the supply line, like the demand line decreases, the supply line increases. So as the price increases, the quantity increases because you're not buying as much, so it just goes into the supply. Okay, so this would have a positive slope. So I'm just doing some basics on lines, showing you slopes and relationships between two variables. So again, the equation of line is y equal mx plus b, where m, the number in front of the x or the variable, is always the slope, and the number by itself is always the y-intercept where it crosses the y-axis. Now we're going to use Excel for our lines, so I'm going to go right into Excel. And the example that I picked, okay, this will probably be kind of short tonight because there really isn't a lot of questions. You don't have a Connect exercise this last week. So let me share my screen. So hopefully you can see this is my Excel example. And if you ever get on the internet and you want to find data, there's a site called FRED, Federal Reserve Economic Data, and it has free graphs, all the data that you could possibly want. And so I got these numbers from FRED, and I picked the years 2010 to 2023. Okay, and I just picked January. They did have the monthly ones. So this is the consumer price index, and the consumer price index is the measure of average change over time of the prices paid for consumer goods. So they're talking about like shelter, and it says all items less food and energy. So we're counting like shelter and clothes and things like that. So there's a number that is figured out to be the consumer price index, and I wanted a real life example. So this is what I picked, and I picked from 2010 to 2023, and the numbers, the CPI is always starting in January. So I picked the ones from January. So you're going to have a table in this exercises, and in the discussion, if you go to week 7, you're going to have the ages of the people now and how much they spent on food. So you're going to be asked to draw the line or find the linear regression line, the line of best fit between the ages of the people and how much they spend. Okay, now to do that, all you have to do is just like we did in week 1. Actually, we did this already in week 1. Okay, we did a scatter plot. So you select your data, and then you go up here to insert, and we just go over to scatter. So we want to do a scatter plot with a bunch of points, and we see a bunch of points and with the dates. Now, the reason the dates are off, I'm just going to delete all those dates. The reason the dates are off in our graph is because of the way I copied the data. I deleted like February through December and then shifted all those numbers up, but they didn't. When you go in Excel, it still thinks you have that data in there that's not deleted. So I deleted the dates. Don't worry about that. You won't have that problem. All I care about are these dots. So in some Excel programs, you're going to have a little plus sign right here on the right. There's going to be kind of a big plus sign. And if you click on that plus sign, you're going to see what I'm going to show you right now. So I'm going to click on one of these dots. If you don't have the plus sign, all you have to do is click on, let me do it again. Just click on any one of these dots. They're going to all light up. So they all lit up. And I'm going to go into, I'm going to right click on one of the dots. So if I right click on one of the dots, I hope you can see this. I can't blow this up. You go down to add trend line. So what we're doing is we're trying to find the line of best fit. You can see that this is looks like an increasing graph. So we're going to try to draw the best line we can through all those dots. And of course, you see it's curved, but we're going to get a line that's called the best fit line. That if we were to draw a line, these points would, not all points are going to be on it, but it's the minimum error that would occur if that we can try to get all these points to line up on that line. So we're going to add trend line. And if you see this chart, we go linear. And it's also called regression. So you see all these other shapes that we could have. We could have exponential, log, polynomial, and that's more from algebra. But we're only going to deal with linear. Linear is line. And then at the bottom, you can see display equation. It's going to give us our line equation. And it's also going to give us this thing called R squared, which I'll talk about in a minute. So we want to click those two. You want to click display equation and display R squared. And we're going to get, I'm going to move it so you can see it. You're going to get this line equation. Let me blow it up. I think I can, no, it won't blow up. Okay, you're going to get this line equation and you're going to get R squared. So that's called the line of best fit, and you get the line. If you see the line, it looks like it goes through some of the points, and some of the points it doesn't. But that line gives us the minimum error of the distance between the point and the line. So I'm going to write down this equation, and then we're going to go talk about it. So line of best fit and regression line are the same thing. Okay, so let me go back. Okay, we got the equation. Okay, this number right here is our slope because it's in front of the x. And this is where it crosses the y-axis. R squared, let's talk about R squared in R. R squared is called the coefficient of determination. And in our case, R squared is 0.945. Okay, what it does, it tells us a percent of the variability of the dependent variable, which is x, that can be explained. Oh, sorry, it's hard writing on here. Let me fix it so you can see it. X, that can be explained I'm sorry, that's y. The dependent is y. By the independent variable x. Okay, so in our case, we have 94.5% of the variation of y can be explained here by x. So, I mean, in this case, in this example I did, x was the date. So as time increases, y is going to also increase. Y was this consumer price index. So that the closer you are to 1 is the most it can be, the better fit that you have. Okay, so 100% would be, every point would be on that line. And if we go back and look, at this, you can see that every point is not on the line, but it's really close. 94.5% of those points are so close that it can be explained by the data. So 100% is a perfect fit, and this is really, really close. So our coefficient of determination is very high here in this example. Then there's also something else they're going to ask you to find. And okay, let me just talk about this. So r squared is between 1 and 0. Anything squared is always positive. So that's an important point. So r squared is always going to be positive. Now, and they use a capital R. Then I don't know why they change it actually, but little r, okay, the other thing that you're going to find is little r, and little r is called the correlation coefficient. And little r is always between 1 and -1, so little r can be negative. And actually, little r is plus or minus the square root of r squared. So if we were to take the square root of r squared, we would get the correlation coefficient, and it measures the strength of the relationship. Okay, when you take the square root of something, you have two answers. You have positive or you have negative. And from algebra, let me just do a side note just to explain that. I'll do that right down here. I'm going to end up erasing it. But if you had this equation from algebra, x squared equals 4, and you were going to solve it, you don't just get 2. You get two answers. You get plus or minus the square root of 4, you get plus 2, and you get minus 2. Okay, now why is that? When you take a square root, you just don't get a positive answer. Why is that? Well, because if you plug those numbers back in and you square it, you would get 4. A negative squared is positive. So when you plug a -2 and you square it, that's 4. And when you plug a +2 in and square it, you get 4. So you always get two answers when you're the one that's taking the square root. Now, how do you decide which one is which? If the line is increasing, if it has a positive slope, then r is positive. If the line is decreasing and has a negative slope, then r is negative. So the closer r is to 1 or -1, that's that's a perfect correlation. 1 or -1 is a perfect correlation. So you want r to be close to 1 or -1. That means the line perfectly fits every point. So if r is 0, there's no correlation. So you want r to be close to 1. Remember, the negative sign just means that the line's decreasing. If it's positive, it's increasing. So in our example, let's go back to our example, Excel. And I want to I want to do this. I want to find little r. So I just click on a there's two ways I could do it. Take the square root or find the correlation coefficient. So we do equals. And to do that, the command is C-O-R-R-E-L, correlation. Okay, so that's the command for little r. C-O-R-R-E-L. And then I put a parentheses and I pick the dates, your first column, comma, and then you pick the second column. And close your parentheses, and that is, and I'll put this little r here, that is our correlation coefficient. And it's really close to 1, which is a good thing because you see that that line really does match those points. Okay, we can also do it this way. We could say equals the square root okay, so SQRT, square root of our r squared, which is 0.945. So we could say the square root of 0.945, and these should match pretty closely. They're not going to be exact because our r squared is only to 3 decimal places. So if r squared was to more decimal places, then we would get those answers closer together. So either one you use is fine. I mean, this one is close, but sometimes they're not all that close. So this one we found using CORREL. This one we found by doing the square root of r squared. And it doesn't matter which one you use. I like using the correlation function because it probably gets you a better answer, closer answer. Okay, again, since that's close to 1 and it's positive, you can see it's positive because our slope is positive. And that tells us we have a really, really good match for that line. It's really a good best fit. All right, now let's see. All right, so I'm gonna just go ahead and go and do another example. Let me ask and see if you have any questions. Does anybody have any questions on that?
I'm good so far.
Okay. All right, so let me just go and look at another example and another Excel example. Okay, so this example is feet per temperature. So I think you know that, like, as you climb a mountain, the higher you go, the colder it gets. So when you're on top of a mountain, of course, there's snow because it gets colder. So you can see that my first column is altitude above sea level in feet. And in the second column, it's temperatures in Fahrenheit. So I want to see if there's a linear relationship between those two. So we're going to draw, the first thing we're going to do is draw a scatter plot. So I select my data. And then again, I go insert, scatter. And I get a good graph. And you can see, yes, it's a line. Okay, linear means line. So this is a pretty good line. Now, I don't know why. Oh, the x-axis is in the middle because, see, I had negative temperatures. It gets so cold down to almost minus 70 degrees Fahrenheit that the zero axis or the x-axis is in the middle. So that's fine. Now, I guess I could change the title. feet versus temperature. That's better. Okay, so again, to get to see if it has if this is a linear relationship, I'm just gonna light up a dot. So again, all I have to do is click on a dot. Now your version of Excel might have a plus sign right here in the corner. In the right-hand corner of the graph, you'll see a plus sign. You just click on that, and then you'll see the same thing I'm gonna show you if your graph has the plus sign. If not, just click on a dot and they all light up. And then I right click on a point and I go add trend line. I want linear. And then I go down to the bottom. And if you have the one with the plus sign, you'll have the same options: display equation on chart and display R squared. Again, R squared is called the coefficient of determination. So I always want both those things. And then I move it out of the way so I can see it better. Okay, so there's my equation. And again, R squared is really close to 1. So you can see this is a really, really good fit. And I did pick points that would line up pretty good. Okay, the closer R squared is to 1, the better the fit. And also, this says that 99.3% of the variation in temperature can be explained by the height. So this is a better example of what R squared is. Again, is the coefficient of determination means that 99.3% of the variation in temperature, which is our Y value, can be explained by our height above sea level, which is the X value. Okay, so that's a real good example of R squared. So let me write this down. Let's go ahead right away and find little r. So I'm going to go over here and say equal COR correlation. And I select the first column, comma, the second column, and press enter. Okay, so notice in this example, this is little r. I'll put little r over here. Little r, which is the correlation coefficient, is negative. And the only reason it's negative is because the graph is decreasing. So r has the same sign as the slope. Notice our slope here, 0.0034, is negative, and that's because our line is decreasing. But again, r is really, really close to -1, which means it's almost a perfect fit. Okay, you could also do it this way. You could say equals the square root of r squared, which is 0.9932. But the only problem with doing it this way is that you have to remember to put the negative in front. Okay, so equal, let me. So it would be -0.99. So you would have to do that yourself if you do the square root. That's why I like the function, the correlation function inside of Excel. And notice they're a little different, but that's because of rounding. On the graph, the r squared is only to 4 decimal places. So these are going to be a little off, but that's okay. So I'd rather have you use the CORREL function to find that. Okay, so I really only have like one more thing to mention. That you might have to do. So the equation of the equation of the line, let's go back and look at let's look at the slope for a minute. If you could also put that over like 10,000 without the decimal point, but if you write it like this, this means for every 1 foot, that's the denominator, the temperature decreases by approximately 0.0034 degrees Fahrenheit. Okay, because the numerator is your temperature. That's what the slope tells us. Rise, remember we talked about that in the beginning, rise over run. Okay, so if we look, let me look at something real quick. All right, if we want to extrapolate, that means predict what's going to happen in the future. We can do that if our R is close to 1. Okay, we can't. If you looked in the if you look at the table for this example, it only goes to 40,000. So if you stay close to 40,000, you can predict what's going to happen later on. But if you go to like 100,000, that's not within our range. Our line might do something like this. It might just go like this and all of a sudden drop. But we only looked at it from here to here. So predicting something way out here is not good. We can't really do that. Okay, we can use it for predictions close by. So if we want to predict it, close to here and maybe on this side to see what happens, it's probably going to continue going down, but we don't know. But again, our line might do something like this. We might have this really nice line on the table, but all of a sudden it might do something crazy out here. So what I'm saying is you can't really predict what's going to happen later on. You have to stay pretty close in to your line to see what might happen. Okay, so we might get a good approximation at 50,000 because that's the next one that should be in the table. Our table stopped at 40,000 and it went up every 10,000 feet. But again, we don't know what's going to happen beyond that. So we can't predict what's going to happen at 100,000 feet. Okay, we don't know if it's going to continue to be a line. So you have to be really, really careful about that. But let's see, all you have to do to do this would be to plug 50,000 into the regression line. So to do that, we would say y equals negative 0.0034 times 50,000 plus 56.834. So let me get my calculator. Again, this would be for prediction, to use a line for prediction, to tell us what might happen outside of the range given. Okay, so we get, when you do that in a calculator, you get a negative 113.7 degrees Fahrenheit. Okay, but we could not predict, say, 100,000. Okay, that's too far away. All right, I think I covered everything that you're gonna work on. Is there any questions on the homework or anything that you've looked at that you might have trouble with, you think?
I have a question.
Okay.
So on the Excel document, wait a minute, let me get to the right one. I couldn't figure out how you said how to spread the data out, and you went to something in the layout and all that, and I could not figure that out.
Oh, on this problem here?
No, when you on the video that you did this week for us to look at, and you talked about it in there and how to spread the data out.
I don't remember.
Inside the chart, like when we create the little graph in there and how you can spread it out, and you said go to the layout and
You mean make it bigger?
yes.
Okay, let me go back to an Excel. This problem, like this problem right here. You mean all you have to make your screen bigger?
No, I know we can drag the. I know we can drag the corners to make the chart bigger. But no, you gave in the video that you posted, you gave some other steps with how to go in there when you was given how to change the name of the X and Y axis and how to spread the data. But it was something that you said in there. You go to the page layout, and go to something. I have to look at it again, but it was something else that you said that I didn't have the option on mine, so I'll just play with it some more.
Well, okay, what you can do is like on this graph right here. Can you see this graph?
Yes.
Okay.
We just see your file screen right now. We don't see the Excel spreadsheet.
Right, okay. Just your files.
Oh, okay. Sorry. Let me go.
And Kimberly, that it stinks because I'm watching her do some of the stuff in Excel, and the web-based Excel, all these menus and stuff like that isn't on the web-based. It's only on the Excel version, so it's very different.
Yes, I was like, I cannot find that. I'm like, what am I doing wrong?
Oh, on Microsoft 360?
Yeah, the installed version is very different from the online version. So that's why I switch to Google Sheets sometimes, because it's very different than what I'm seeing right now.
Huh. I'll check into that. But yeah, you can use Google Sheets. That's fine. You don't have to do Excel. I'll take Google Sheets. I didn't know that because I just use this Excel. I mean, it's too late now, I guess, but if I can go in there tomorrow, though, I could do in the morning, look at Microsoft 360 and make a different video and show you where those options are. I'll try to do that early in the morning. But for here, if you just click on the point and go to the layout is right on top. If you see chart tools, layout, there's like the axis titles. You can do the primary, let's see, title before that. There's a title right there. And then again, layout, chart title, and axis titles. You could do the vertical title, and that gives you the title there. But I'm not sure about what you're talking about, the spread, because for linear or line, I wouldn't have spread that out. Are you talking about like a histogram?
No, it was in the video that you posted this week.
I'll go back and watch it, and I'll watch.
Yeah, I'll go back and tell you exactly where it was, but it was when we started out opening up the chart and saying you could spread it out this way. When you said it was something about going into the page layout and going somewhere else, and it wasn't just clicking on the plus, it was in the toolbar menu. And of course, it wasn't on my version, so maybe that's just what it was. I have to do it a different way.
Okay, so try clicking on the points. Try clicking on the points, and then you'll get like, see up top here, you get chart tools, design, layout, and format. So if you go layout, you can get all the labels, but when I click on the point and then right click on it, then I go to add trend line or format data series. But I'll do that. In fact, I'll look at it real quick after we leave tonight and maybe do a quick video on the Microsoft 360.
Okay. Okay, that was
I'll
it.
send that out.
Okay, that was it.
I wasn't sure that was different. I didn't know it was different. Any other questions?
Oh, wait a minute. Let me see. So in the one of the questions in the homework in the discussion was about not the one about the 84-year-old, because we didn't have an 84-year-old, so we would just state that, right?
No, that's just what I was just talking about now. When I did the temperature problem, and the table only went up to 40,000.
Right.
Then
okay. So this is the same thing.
Yeah, I plugged the 50,000 into the equation. So you could plug the 84 into the equation, but then notice that, well, 84 might be way too far away from the last age on the chart. So you could talk about that. So you might want to explain that. Well, somebody that's 84, maybe isn't working there anyway, or
right, because it's too far. Because I'm like,
too far. Yes, that's the point of that question.
Okay, I was wondering that. I'm like, is a trick question? Okay.
Okay, I'm trying to sign into the 365 and see.
Yeah, I found it really hard to identify the equation and R2 values in Office 365, so that's why I use Sheets. It was just a lot easier in Sheets.
Yes, I had to do a lot to try to figure out where that was. I mean, I finally figured it out, but it was not easy.
Okay, I mean, if you want to stick with me, I have it open. Let me copy the data I have here, and I'm gonna go to. I mean, if you can't stick with me, that's fine. I'm just gonna try to figure this out. And I'm gonna go to. Okay. Let's see. Where is it? Oh, right here. Can you see that?
We only seeing your documents.
I'm not used to this thing. Okay, share. Stop sharing. Okay, can you see now?
Okay.
Can you see the table?
No, we got no.
Really? We just see your Office 365 window.
Your Office 365. That's it.
Oh, sometimes it's like, I know why you get so frustrated with okay, share application. I want to. All right, can you see it now?
Now we see it.
Okay, thank you. All right, sorry. All right, so I want to insert the scatter plot. So I'm going to go to insert. Yeah, and it's over here. So I'm going to pick scatter. And then I'm going to click on the dot. And let me see, format. So if I click on a dot, I can get the horizontal axis, vertical axis, and the chart title. But I don't want to do that. I want to get a line. So I wonder why they're not the same. I'll have to go to help. What did it click on? Oh, you have to use you have to use a command there. The Linus function. Show tread lines. Select a 2D. Oh, you're right. It's all different. Double click the chart to open the chart pane and select format. Expand a series for your data and select tread line. Double click to open the chart. Oh, okay. So you have to you have to double click on the graph, go to format. Okay, watch. You're going to double click on the graph. It opens up chart on the right. Then you're going to go to series temp F, and tread line is right here, and you turn it on and it draws your line. Okay. This is way different. And then you want to display R squared and the equation, and then you got it that way. All right. Okay. So did you see what I did?
I did.
Okay. So Microsoft on Microsoft, what it said to do, just what I did was search for tread line. If you don't remember, and it tells you how to do this on the right. Then here, let me delete this. Let's start over. Okay, so we're going to go select the data, insert
the scatter.
Scatter, yep. Okay, double click anywhere on the chart. So left click, double click, and it opens up chart format. So that's all I did was double click in this series 1, go all the way down to tread line. turn it on,
Turn it on.
and then display equation and display R squared. So if you want to use that, you can. If you don't want to use it, then go ahead and just use Google Sheets. That's fine.
Okay.
So does a command work? CORREL?
Well, I hadn't tried it yet. I didn't know that command, so.
Okay, that's fine. Yeah, it does. CORREL, and then you pick.
Select the data in both columns.
Yes, and then comma, and there's your R. That's little r. So that's your coefficient of correlation, and this R squared is your coefficient of determination. So that's the way you do it in Microsoft 365. So thanks for pointing that out. I didn't know they were that different. Okay, so I learned something tonight.
Good stuff. Good stuff.
Yeah. So next week is the final. Let me just say this. It's nothing to panic about. You have a whole week and there's not many questions on it. Less than, say, 10 questions with parts. I think there's like 6 questions. So no worries. I think there's just 1 question out of each week. So maybe 7 questions out of each week. So if I won't do collaborate just because there's no new material, but if you have questions, all you have to do is contact me and we can do this, separately, one-on-one. So we could do, that's how I was going to do next week. So if you have questions, we could do it at a time that's convenient for you. But anything else about any of the material?
There was one question. Let's see. So in the can you hear me?
Yeah.
Oh, okay. So in where we start, so open the Excel spreadsheet, is that number 1? Because the last question says, how much do you trust? How much trust do you put in the answer for 5 and 6?
Let me look. So, I know. I just saw that today and I didn't want to go in and number it. I don't know.
Right. And I'm like, because the way it looks like number 1 should be where it says create the scatter diagram, and so that will make 5 and 6. So it
yeah, that's a good question. Hold on, I have it. Assignment right here. Okay, so the discussion. All right, so it would be 1 is what evidence, if any, supports the claim? No, that's discussion 8. I'm sorry. Discussion 7. Oh no, 5 and 6 is the 36 and the 84.
Oh, okay.
Five is how much money would a 36-year-old employee want, and then 6 is the 84-year-old.
Okay.
Sorry about that.
Okay, no worries. I'm like, I'm thrown off. Okay.
All
Okay,
right.
that's
Well,
it.
if
I
you
don't have any more questions.
okay. Yeah, thanks Brandon, thanks Charity, thanks Kimberly for coming on. If you run into anything, you know how to contact me.
Okay.
All right. Well, have a good week. And again, for the last week, if you need help, we'll just do it on one-on-one.
Okay.
Thank
Okay.
you.
We'll
Have a
see you
good night.
guys later. Have a good night.